another two important numericals on projectile motion. To understand this problem and its analysis, we need to understand the momentum and the principle of conservation of momentum. Momentum symbol is P. It is a vector quantity, therefore it has both magnitude and direction, and is defined as mass into velocity. Suppose in some situation this mass into velocity, when represented, because it is a vector quantity, is this much to this side. Let's say this is equal to 10 units, and something happens, and the conservation of momentum says after some happening it has to be same, means it has to be 10 units as it was before, and the direction should also be the same as it was before. Before the direction was this, and now the direction should be this. Before the magnitude was represented by this length, which is 10 units. Now it should also be represented by the same length of the same units. That is a conservation of momentum. Now let us go to the problem. A projectile of mass 2m, is projected from horizontal ground. From here, a mass 2m is projected from this horizontal ground. This is your horizontal ground, making angle theta with the horizontal. This projectile of mass 2m is projected with a velocity u, making angle theta with the horizontal. At the highest point, this is the highest point. At the highest point of its path, it breaks into two equal parts. Since the initial mass is 2m, and if it breaks into two equal parts, each part will be m and m. It breaks into two equal parts, m and m. One of them fall straight down. One of them, either this or this. From the highest point, it falls straight down, arrives at B, falls straight down. What will be the range of the second one? Suppose this m falls from here to here, then this m will arrive where? On the horizontal ground, means the range of this from the point O. What will be the range of the second one? And in the same problem, in the above discussion, if one mass m retraces the path from this point after breaking into two pieces, if one of them retraces the path and arrives at O, then what will be the range of the second m, where the second mass will go and fall? Now this is very simple. We need to apply conservation of linear momentum, which is mass into velocity at the highest point. Look, this is your velocity of projection u at O. Therefore, if you break into two rectangular components, this is one component, horizontal component, that is u cos theta, which does not change because there is no air resistance to this side. This u sin theta goes on decreasing because earth is pulling it down due to acceleration, that is minus g. So this becomes 0 here, but here we are left with only u cos theta at the highest point A. Now at the highest point A. Now the analysis part of it. Now look at, let's just explain to you. Let's let use the velocity of projection at O, u angle of projection at O, u cos theta the horizontal component, that is this much, u sin theta the vertical component, that is this one. We know u sin theta becomes 0 at A here. 2m, mass of the projectile before breaking. It breaks at point A. Before breaking, the mass was 2m. Now mass of the projectile before breaking is 2m. When it breaks into two pieces, one piece becomes m and the other becomes also m. At A, at the point A, that is just before breaking, the mass at A was 2m, the velocity was to this side, u cos theta. So mass into velocity is momentum, so that is equal to 2m u cos theta along positive x-axis. This momentum has a direction to this side along positive x-axis at the point A. Now at A, just after braking, one piece M falls straight down at B. One piece, that is 1m, from point A falls straight and arrives at B. This is possible if its velocity becomes 0 at A. The one that falls down from A to B, if its velocity becomes 0 here only, then it will fall down at B. Therefore, since its velocity is 0 at A, its momentum will be mass into velocity, that is equal to 0. For the one that falls straight down, now let V is equal to velocity of the second mass. Now, so the momentum of the second mass M will be mass into velocity. So total momentum after braking is 0 for the first one that falls straight, and for the second one M into V, MV. So is the total momentum after braking, total sum of the momentums of the two pieces after braking, and this was the momentum before braking. And this can be represented as 2 mu cos theta I cap because it is along x-axis. Now apply conservation of momentum. Now according to conservation of momentum, the present momentum must be equal to the momentum before. So mv is equal to 2 mu cos theta I cap. So mm cancels. So we are left with v is equal to 2 u cos theta I cap. That is the second piece M will have a velocity 2 u cos theta, and this is nothing but 2 times u cos theta I cap. Now look, when it was traveling like this, it was falling here. Due to u cos theta, it was arriving here. Now the second piece has a velocity 2 u cos theta. So it will arrive at a distance twice of BC, that is at a C dash. So it will fall at C dash such that BC is equal to CC dash, and BC is nothing but half of OC. OC is written as R. So BC will be R by 2. So CC dash will be also R by 2. So the range from O will be this R by 2 plus this R by 2 plus this R by 2, that is equal to 3R by 2. Now the second part. Now if one of the pieces retraces the path, one of the M retraces like this. If it will retrace the path, then it has to have the same velocity u cos theta to this side. So momentum of the piece retracing the path will be its mass into velocity, but to this side, that is minus I cap. Let V2, which we don't know, be the velocity of the second piece after braking. So its momentum will be mv2. Therefore, so the previous momentum before braking was 2 mu cos theta I cap along to this side, and the present momentum, this is for the momentum of the second piece that is retracing the path, and this is the momentum of the one that is left, which velocity is v2 have taken. So this comes to this side, becomes 3 mu cos theta, I cap. I am left with mv2. So mm cancels, so vt is equal to 3 u cos theta I cap. Means when one piece retraces the path like this due to u cos theta to this side, the second piece, which velocity I took it as v2, this comes out to be 3 u cos theta I cap, means 3 times u cos theta. So due to u cos theta here, it was arriving here. So due to 3 u cos theta, it will arrive 3 times this distance r by 2, r by 2 plus r by 2. That is from here at a distance r by 2 plus r by 2 plus r by 2, 3 r by 2. Or you can say from here it will be equal to 4r by 2, because from here to here is also r by 2. So it will fall at C dash such that BC double dash, so such that BC double dash will be 3 times BC, because due to u cos theta it was arriving here, from here to here is BC. Due to 3u cos theta it will arrive at thrice the distance BC, that is this plus this plus this, that is at C double dash. So 3r by 2. Therefore range from O, therefore from the point O, C double dash will be 4 times r by 2, that is equal to 2r, that is equal to 2r.